You see it on the news all the time, right? Devastating fires on one side of the world and catastrophic floods on the other. They seem like completely random, unrelated disasters. But what if they're not? What if they're actually two sides of the very same coin? What if there's a single massive climate engine in the middle of the Pacific Ocean that's pulling all the strings? Well, there is. It's called the El Niño-Southern Oscillation, or ENSO for short. It is, without a doubt, the most powerful natural climate pattern on our planet. But does it actually create more superstorms? To get to the truth, we have to follow the science. All right, let's get into it. To really understand what El Niño is, you first have to understand what normal looks like in the Pacific. We call this the neutral phase, and it's all run by this giant atmospheric loop called the Walker circulation. So here's how it works. You've got these steady trade winds blowing from east to west across the Pacific. Day after day, they push the warm surface water heated by the sun over towards Australia and Indonesia. I mean, it literally piles up into a massive warm pool. All that warm, moist air rises, creates a ton of rain over there, and then cycles back high in the atmosphere, sinking over the cooler waters off of South America. It's a really neat, balanced, self-reinforcing engine. But then, you get an El Niño, and that whole engine just breaks down. The trade winds get weak, or they even reverse, and that giant pool of warm water comes sloshing back east across the ocean. And guess what follows the heat? The rain. The entire system flips on its head. This is why you get those catastrophic floods in Peru, which is normally dry, and terrible droughts and fires in the Western Pacific, which is normally wet. And then you've got its counterpart, La Niña. Now, if El Niño is the system breaking down, La Niña is like putting it on overdrive. It's a supercharging of the normal state. The trade winds get even stronger, piling that warm water even higher in the west, which causes a huge upwelling of cold water in the east. The result? Insane amounts of rain for places like Australia, while parts of the Americas can get plunged into a serious drought. Okay, so we've got this huge pendulum of warm and cold water swinging back and forth across the Pacific. How in the world does that affect the planet's deadliest storms? Well, to figure that out, we first have to look at the basic recipe for a storm. And first things first, let's just clear something up. You hear people talk about hurricanes, typhoons, and cyclones, but scientifically, they're all the exact same thing, a tropical cyclone. The name just changes depending on where you are in the world. Same beast, different names. Now let's get to that recipe. You really only need two main ingredients. First, the obvious one. You need fuel, and that means warm ocean water, specifically at least 26.5 degrees Celsius. But the second ingredient, that's the one most people don't know about, and it's the one ENSO has almost complete control over. It's the kill switch, low vertical wind shear. So, what on earth is vertical wind shear? It's basically the change in wind speed or direction as you go higher up in the atmosphere. Just imagine the air is made of different layers stacked on top of each other. If the top layers are moving way faster or in a different direction than the bottom layers, that's high wind shear. For a storm to build, it needs that whole column of air to be moving together. High shear just tears it to shreds before it can get started. I love this analogy. Think of a baby storm like a tall, spinning chimney. It's trying to suck up all that warm, moist air from the ocean to power its engine. High wind shear is like a brutal crosswind that comes along and just blows the top right off that chimney. It kills the engine. It stops the storm dead in its tracks. And that brings us to the biggest misconception out there. People hear El Niño, they think warmer water, and they automatically assume that means more fuel, so more storms. But the science, well, it tells a very, very different story. So let's just ask the question directly. Does ENSO, either El Niño or La Niña, actually create more tropical cyclones around the world every year? The answer, based on all the data we have, is a clear, emphatic no. The total number of storms that form around the globe each year is actually remarkably stable. The real story isn't about multiplication. It's about relocation. And this is an absolutely critical distinction to make. On one hand, you have ENSO. It's a natural pendulum, swinging back and forth. Its job is to relocate storm risk. It changes where storms are most likely to pop up. On the other hand, you have climate change. That's a long-term, unnatural trend. It doesn't necessarily make more storms, but it intensifies the ones that do form, making those terrifying Category 4 and 5 monsters more common. So, you want proof of this relocation idea? It becomes crystal clear when you look at how different oceans respond to ENSO. It's like a perfectly balanced seesaw. Okay, check this out. During an El Niño, the atmosphere changes in a way that creates high wind shear over the Atlantic. Remember that storm-killing chimney effect? It's like a giant protective shield that tears hurricanes apart. But at the exact same time, that same pattern creates low shear over the eastern Pacific, basically rolling out a welcome mat for storms. Now during La Niña, the whole thing flips. The Atlantic gets the welcome mat, and the eastern Pacific gets the shield. When one basin is active, the other is quiet. It's relocation in action. So let's take this global pattern and zoom in on one of the most storm-battered places on the planet, the Philippines. See, this part of the world is a bit different. The water in the Western Pacific is pretty much always warm enough to cook up a typhoon, so the fuel isn't the limiting factor. The number one thing that determines the risk to the Philippines is a storm's starting location, where it's born. And this creates a really dangerous trade-off. During an El Niño, typhoons tend to form way out east, far out in the Pacific. This means you actually get fewer storms hitting the Philippines overall. But, and this is the deadly twist, the storms that do form have a very long runway over warm open water to grow into absolute monsters. So you have a higher risk of a super typhoon. Now, during La Niña, it's the opposite. Storms form right on the Philippines' doorstep. The result is way more landfalling storms, turning the country into a virtual typhoon magnet. And this table just lays it all out. You can see that perfect seesaw in action between the Atlantic and the Eastern Pacific. And for the Western Pacific, you can see that complex, dangerous trade-off. El Niño means fewer storms hitting land, but a higher chance of a monster. La Niña means more storms more often. It's the whole global system all in one view. So we've looked at the mechanics, we've looked at the data, and we've looked at what happens on the ground. What's the final verdict on ENSO and global storms? The science is totally clear on this. ENSO does not create more storms. Its proven primary effect is a global relocation of risk. It does this by flipping that atmospheric kill switch, that vertical wind shear, back and forth across the planet. And for vulnerable places like the Philippines, that creates a terrifying trade-off between how many storms you get and how strong they might be. But we have to end with the single most important takeaway here. This completely natural cycle that we've been talking about, it's now operating on an unnatural hotter planet. So while ENSO is busy aiming the storms, deciding where they're going to go, human-induced climate change is loading the dice, amplifying just how destructive they'll be when they get there. And that really leaves us with one final, sobering thought. We know ENSO is the natural pattern that aims the risk, shuffling it around the globe. The real question we all have to grapple with now is, what is the unnatural trend that's amplifying the damage every single year?